I found that students have a hard time with interval notation and remembering exactly how to write it. So listen very, very carefully. If I say x is greater than 5, and I were to graph it on a number line, I'm just going to throw a 5 in right here. And if x is greater than 5, then I have an open circle, and then I shade everything bigger than 5. In interval notation, when you express x greater than 5 in the interval notation, you need to write it as you see it on the number line. So I'm going to put a positive infinity right here. You need to listen to this. When you write the interval notation, it must be in this order. It's the left edge of the interval, if you were to graph it on a number line, comma, the right edge, if you were to graph it on a number line. Infinities always have the round brackets. If you do not have an equal to sign, then it's not included, and we do a round bracket on the 5. If I look at x greater than or equal to 5, when I graph the answer, I fill in the circle on the 5, as well as shade to the right of it. And I'm going to put an infinity here on the right because you must put it in the order of the left edge, comma, the right edge. Infinity always gets round brackets. But if the endpoint is a solid endpoint, you have an equal to, then it's almost, I can almost picture that parentheses being stopped by a wall suddenly, and it smushes the parentheses. And then makes it a square bracket. And then I want to point out that if you have x less than, say, the number 6, and it's or equal to, so I'm going to fill in the point, the left end is negative infinity. But when you write this interval, you must write the left edge, comma, the right edge. It must be written in that left to right order. Infinities get round brackets. If a point has an equal to sign, it gets a square bracket. Then to point out these three, we have intervals between -2 and 3, and various issues of whether the endpoint is included or not, just to make sure that you are clear. When you are graphing the interval on a number line, open circle if you don't have an equal to, closed circle if you do have an equal to. And when you express the interval notation of this number, it has to be the left edge, comma, the right edge, and then round if it's not equal to, square if it is equal to. Now I'm taking a side trip over to solving inequalities. I've noticed that inequalities kind of get thrown into the Math 3 homework without reminding you of like what goes on with inequalities. So here's the thing. If you need to solve an inequality, in other words, take a look at what I've got here. These are inequalities. where instead of an equal to sign, you have greater than, less than, and then maybe equal to as well. You're going to solve these just like you would an equation. Your goal is to isolate the variable. The only time you have to think about it being an inequality is one particular issue. If you multiply or divide by -1. So what I want you to do is take a moment to think about why multiplication by -1 causes you to have to switch the sign. And so I've got an example right here to help you see it. If you take a negative number and a positive number correctly positioned in a number line, so the negative line is on the left, the positive side is to the right. If you multiply both numbers by -1, do you see that they switch who is to the left and who is on the right? That happens if you multiply by -1. But if I subtract 1, I'm not changing the order if I subtract 1. If I subtract 1 and I go down to -6 and 2, that doesn't change which one of those is bigger versus smaller. It's only the multiplication, which is similar to division by a negative number. And just to point out, if you have two positive numbers and you multiply them by -1, they both become negative, but do you see that they swap who's bigger and smaller? And then if you start with two negative numbers and you multiply them both by -1, making them positive, they again swap order. So now let's take a look at solving these. This is review, or at least I'm pretty sure it's review. Now, you can temporarily go, hey, what if that was an equal sign? If you need to do this to help you understand where to go with inequality solving, temporarily put an equal sign in there. For some reason, that affects your eyes to go, I recognize that and I know what to do. But you have to be careful about remembering who that actually is. So if you think about it, you need to get the x's on one side, and you can do that by subtracting x. I'm subtracting x, but I am not multiplying by a negative, and I am not dividing by a negative. I don't have to change the direction of my inequality when I subtract. Then when you look at it, you remember, oh, to solve that, I add 5 next. And then up, divide by 6. You can reduce the fraction, but you need to go back to the fact that it actually is an inequality. I never multiplied or divided by a negative number, so that means I can just take the inequality sign and bring it back exactly the way that it was. There are a lot of you that I'm telling you right now, I recommend that you just rewrite that inequality symbol with an equal to symbol. It will visually stimulate your mind to think about equation solving, because that's really what you're doing. There's just a minor extra issue to be on the lookout for. So know that you are going to be expected to write the solution in interval notation and graph the solution on the number line. I'm going to go over to the answers to save a little bit of time. When you write your answers on a number line, just write the number orders anywhere you want. Now with number 2, that one you do have to be careful with. I'm multiplying by a -4 to isolate that y. Now I'm going to go back over to the classwork and just talk about if you see this in front of you. You can temporarily write that inequality as an equal to sign to stimulate your memory of how to solve equations. Maybe what you first see is multiply by -1. Be aware that you just multiplied by -1. That causes this to swap. So right now that has been changed to the other direction. But again, people see a lot better what to do with an equal sign than an inequality. You see, oh, multiply by 4. All you have to do is bring that inequality symbol back in the correct direction. And I'm just telling you, if your eyes look at this and understand what to do, but look at this and feel frightened, replace the inequality with an equal to sign. Your mind will kick in with the things it knows to do. Okay, now these next couple of problems are compound inequalities. If you have something in the middle, the quickest way to work with it, and I'm only going to give you a certain level of inequality problems. If I give you a triple like this, I'm going to put the variable only in that middle section. If that variable is in the middle section, then what you can do is think, if I saw that on one side of an equation, what would be my steps to isolating the x? I would first subtract 7 to both sides, and then I would divide by 2. So let me actually... and then my x would be isolated. Do those two things in that order to all 3 pieces of this inequality at once. So I'm going to first subtract 7 from all 3 sides. 13 minus 7 gives, nope, hold on, I can add, I really can, 6. And then subtracting 7, the middle is now 2x. Subtracting 7, the right end is now 10. Then divide by 2. Now I'm dividing by a positive number, so I don't have to worry about switching the direction of the inequality. If this was a negative number, both inequalities would completely switch over. And then from there, you're expected to draw the solution on a number line and write this in interval notation. So I'm going to show you those answers. I'm trying to just show you this one and not the other one. Wait, that's not the right one. It's this one. There we go. So we just saw getting to here. For a final answer, you need the interval notation and you need the interval. Okay. Back over to here. This is two inequalities with the word or in between them. Or means any solution that works for one or it works for the other is all good. Do you recall doing union? Did you guys do Venn diagrams and look at what union is? The word or is union. We're not looking for what is shared by both. We are looking for anything that is in one, in the other, or even shared. All of it is allowed in with the word or. So now you have two inequalities to solve. For this one, I need to add 2 to both sides. For the second one, I need to subtract 4 from both sides. And again, subtracting doesn't change the sign around. It's multiplication and division by a negative. And with this, what you can do, I like to draw the number line solution to help me answer the intervals. I've got two numbers, -1 and -7, and I need to think what order are they on a number line. Then, if y is greater than -1, then I'm shading here. If y is less than or equal to -7, I'm shading less than, and I've got to make sure to fill in the point. And now I'm going to put up the answers.
Isn't that an undefined answer? Since that's technically impossible, isn't it?
Well, with the word or in between, there's an understanding that that word means anything that's a solution to one inequality is a solution to the whole. And if the word and had been used, this would have been no solution. And it's really, really important to know the difference between those two words when you're working with inequalities. Or means if you're, it's kind of like, I guess, if you have two friends and you are in elementary school and you tell your friends, you know what, your friends are my friends. Oh, wait, and my friends are your friends. The more we get together, the happier we'll be. That song takes on a sad meaning right now. Oh, dear. So it's just important that you know the word or means if it is an answer to one, it's an answer to all. Everybody is included. If this had been, and I can't emphasize this enough, if instead of or it was the word and, it would be no solution. And is intersection. So with a Venn diagram, just this, where the word or is union. Okay. Then next. Next, I have for you an inequality word problem. I want you to know that I have kept your word problems down to a minimum. With the curriculum of Common Core, you're expected to be able to read through a paragraph and understand the paragraph in mathematical words. Some of them are really, really awful. So I'm trying to lighten it up with Frodo. You know, The Hobbit? So just picture poor Frodo is delivering boxes of paper to each floor in an office building, and like this big giant pack of papers going over Frodo's head, and he's like, ah!
Frodo.
What?
Sam's the one that did all the work. I mean, he carried everything the whole time.
Sorry if I hurt your ears with that screech. Yeah, that you just made me laugh. Okay. So this is just trying to make sure that you do understand how to take a bunch of words and make an equation out of it when that's what it's meant to do. Okay, so let's look at it. Imagine boxes filled with paper. Each box weighs 20 pounds. Frodo weighs 43 pounds. The cart he uses to carry the boxes is 55 pounds, just to, throw it in there like, ha, 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 ha. Ha, ha, ha. We're torturing the Hobbit. Now, the maximum capacity of the elevator that Frodo desperately wants to take is 2,000 pounds. So Frodo wants to know how many boxes can safely be taken up each elevator. This is very important to Frodo. Frodo does not want to make more trips than Frodo needs to. So as you analyze just these little pieces that I highlighted, analyze what each one is saying. And realize that some of these numbers are just occurring once, and that's it. We don't get to have two. Frodo does not duplicate himself and become two Frodos. 43 pounds is 43 pounds. He can only push one cart at a time. We could picture maybe something otherwise, but there's only one cart. These two measurements are the absolute beginning number, but won't change. No matter how many boxes Frodo takes up that elevator, the weight is going to start with that number. The question is how many boxes? So we can let X represent the number of boxes. If each one weighs 20 pounds, I'm adding that weight on to the weight that already has to be there. But it's based on how many boxes. So the number of boxes multiplied by 20 will give me the total weight of these boxes worth of paper. I need this to not exceed, darn it, it's 10:40. I need this to not exceed 55 pounds. I'm sorry. I was looking at the wrong spot. I need this to not exceed 2,000 pounds. And you can write the 2,000 on either side. You just need to think about when I have an inequality, if I write down the number and the expression, I will actually put in my two hands an imaginary 2000 and imaginary that expression. Which one must be bigger? And then I think about it as like I'm have two things and I'm weighing them, which one has to weigh more. And I use that kind of thought to help me figure out which way the inequality should go. I need that 2000 to be more, right? And whether you like it or not, the alligator eats the largest thing. From there, you can solve the inequality. And I've got the answers in the classwork. Oh, I was going to do that too. Okay, so here are the answers. I've got to start you on your STAR test. Before I go, though, I want to point out to you that the rest of your classwork is some more review of how to sketch piecewise functions. If I can remember to do it, I need to make another video where I explain the piecewise functions if you need help. But I do have the answers. Just the answers are without explanation. What?
Oh, I was just saying for this classwork,
Mm-hmm.
this Frodo question.
Mm-hmm.
I just thought about it in my head, and when I did, I just got 95. It showed in your answer 95.1, but wouldn't you just kind of just I just said
Mm-hmm.
well, I said x is just about equal to 95 because you can't really take 0.1 of a box, and you kind of have to change your measurement, right? You would
Exactly.
I don't know. It's just something you could, I'd probably just add in the and like if I was being tested, I'd probably just put just about 95, and then in the writing portion, I would probably put he could take up 95 full boxes in a small bag of paper. I don't know.
Yeah. So I am a big fan of if you can logically think through this in a different way, do so. I think everyone thinks differently. You shouldn't be forced to think in a very specific way. When tests come around, when you have to do standardized testing, which we're about to do. So, yeah. The big thing is you do need to be able to write an inequality.
Well, I like that because my old because when I did honors math, oh my god, this is the stuff I'd get docked on.
Yeah.
I would write 95.1, and then I'd just see on my test 0. I'm like, wait, what?
Yeah.
You can't take a partial box, otherwise it wouldn't be a box. It's like, oh, come on. I did all the work, and then you're gonna tell me I can't take a partial box? Take a box cover.
Oh, I feel like this suddenly changed to a therapy session on math class. And it's very, very common. Sadly, it is extremely common. I'm going to stop